Morning.
Did you get the homework file changed?
I got the 2.2. I think you already had 2.1.
Yeah, I got 2.
And I haven't graded 2.3 yet. So, but those will be in today. Okay, all right. All right, okay. Let's get this started. We're going to start out today with an ACT question, a 47. So that's like, what is that? Okay, let's do the math really quick. 47 out of, oop, that's not right. 47 out of 60 times 36. So that's like if you're looking to get like a 28, 29 on the ACT. We need to find the domain of this function. I'm going to give you 1 minute, just like on the real deal. Good luck. So to be honest, I don't know. Maybe I'll give you a minute 15 because ideally you're supposed to be banking time for the later questions by doing the early questions faster. Actually, it wasn't so bad as I thought. All right. All right, who's got an idea of how to start? Nobody? What numbers can we not plug in for x? What would create a problem for us? 0, right? We can't get 0 in the denominator. That's right. So x cubed minus 9x cannot equal 0. If we equal 0, then when we try to divide 2 by 0, our calculator will explode. And then you'll be escorted out of the ACT because you created a distraction for the rest of the students, right? Of course. All right, how do we solve this for x? Well, what have we been doing to solve things for x? We're looking for factors, right? If we could just factor this down into just linear x's where everyone has a power of 1, right, then we can get this problem done. So what can I factor out of these two? X. And then what I would have left is x squared minus 9, right? Well, that means, right, that means x can't equal 0 and x squared minus 9 can't equal 0. So actually, we already know that A, B, and C are not the right answer. Right, it's down to D and E. All right, how would we solve this one for x? It's 2 steps. Yeah? Add 9. So x squared can't equal 9. Okay, now this is the big deal. This is why this question is labeled number 47. How do we get rid of the squared? Square root. Okay, I'm going to write something that's wrong, and then you're going to tell me why it's wrong. That's wrong. What's wrong? It is a plus or minus. That's why this is question. That's why this is the 13th hardest question on the ACT. You have, whenever you get rid of an x squared, we have to put the plus or minus, because 3 times 3 is 9, but -3 times -3 also makes positive 9. So the answer is E. All right. That's one way to do the problem. Now let me tell you the unethical way to do the problem. You just plug in the numbers, right? And see which ones your calculator says it can't do. And to be honest, you see there's a lot of duplicates, right? 3 is in here 4 times. So if you test 3, you already know that A is not going to be a choice, right? And if you plug in 3, it's not going to work. So then it just becomes, does 0 work? You could probably do that one in your head. And then it just becomes, well, what if I plug in -3? So really, you could get this answer by typing 2 things into your calculator. 2 over parentheses 3 cubed minus 9 times 3, and 2 over -3 cubed minus 9 times -3. Do you mean the power of 2 here? When we square rooted it. Oh, shoot, you're right. You're right, Vanessa. I should have wrote it like that. I should have wrote it like this. And then the square root and the squared cancel out. All right, questions about this? Okay. Here's what we're learning about today. So that was just your warm up. To be honest, it doesn't have a lot of application of what we're doing today. Here's what we're doing today. We're going to cover this and a pre-calc review thing. You can set that on the floor, by the way, if it's blocking your view or anything. And then this we'll probably cover on Monday. Actually, we do this one today too. We do a little bit of A and B, and then we'll finish B, C, and D on Monday. There's no homework due Monday. The homework got pushed back to Wednesday. But because I think we ended up having to do more Algebra 2 review than I thought we would need. But that's okay. It's important to review. All right. So first thing in your notes. Today we're going to talk about how to use complex numbers. To use complex number, we first have to understand what is I. I is called an imaginary unit, not because it's like made up or fake or not real or anything, right? It's not imaginary in the way unicorns are imaginary. They just label it imaginary because I is the square root of -1. And traditionally, you can't square root -1, right? Because if you think, what number can I multiply by itself to get a negative? It's impossible. right? A negative times a negative is positive, and a positive times a positive is positive. So it's supposedly impossible to multiply something by itself to get -1. I thought I fixed this for this slide. Okay, there's a big typo. Don't go too far when you're writing this. A huge typo. So I then is just the square root of -1. It's our placeholder. Wherever you see the square root of -1, you can put I. Wherever you see I, you should understand that that's just the square root of -1. So what that means then, I squared, and this is the big typo, is equal to -1, not +1. I feel really bad about that. And that should make sense to you, right? If I is the square root of -1, then the square root of -1 times the square root of -1 would be the square root of -1 squared. And then the square root and the squared cancel out, right? Just leaving you with -1. Oh gosh. Right. So the idea here is I times I is just I squared. And again, that's -1. All right, for this second part, you do not need to write down all of these things. All this paragraph is telling you is that we can now write numbers in complex form where A plus BI, A and B are real numbers. The first part we say is the real part. The second part we say is the imaginary part. So for example, 2 plus 3i is a complex number, where 2 is the real part, 3i is the imaginary part. Does that make sense? Okay. And this is another thing, again, I can't stress it up. I get some people that every once in a while that's complain to me and say, Mr. Lake, why do we learn this stuff? It's not real, it's imaginary, all that kind of stuff. Imaginary is really a misnomer for this concept. There are a lot of real world practical implications for this. One of the best is this allows me to write down any number then in terms of two terms that cannot be combined, and then I could use that to do pretty much or represent anything in a two-dimensional plane with just a single number then, where the real part would be the left to right direction and the imaginary part is the up to down direction. So there's a lot of stuff where they used to program TVs like that, where every pixel would be given a complex number. So it'd be like 5 over and then 3i up. And then they would just know that in the programming that that's talking about this pixel, and then we can assign it a color. We do that to every pixel of the grid, and that creates the image you see in front of you. Right. So don't let the fact that it's called imaginary mess with you at all. All right, does everyone have this written and this written? Does anyone need more time to write those two things? All right, if you do and you're just being shy right now, remember all the notes are in the Google Classroom, so you can copy and paste at your leisure. All right, for this slide, all you really need to write down is, and I almost debated on whether or not I was going to lecture over this at all, because it's a little obvious. If we say that two complex numbers are equal, what that means is that A and C have to be equal, and B and D have to be equal. Which is exactly, I mean, what you would think. So for example, if I said 2 plus 3i was equal to C plus DI, that would mean,
So would both of the B and the D be both imaginary since they both have the I with them?
yes, yep, that's right. That and that are the imaginary parts. That's exactly right. And then the A and C would be the real parts. And together, real plus imaginary makes a complex number. So in here, since my real part is 2, that means C would have to be 2. And since the imaginary part is 3i, that would mean D has to be 3. Make sense? In order for them to match, the parts have to match. Okay, you ready for some Algebra 2 review with a pre-calculus twist? And again, this is, I don't know, I feel like maybe all of this is review. You've seen I before, right? A little bit? A little bit? No? A little bit? I'm gonna have to send an email to Ms. McFadden and be like, what did you teach these kids? I think it's a long time ago. All right, anybody need time to write down these 3 things? Okay, okay, all right, all right. All right, here we go. What you all have been waiting for. Let's do some examples. Okay, here's how you have to do this arithmetic with I. The first step that you have to do is separate your components into stuff you can square root. Okay, so first step is you separate into stuff that you can square root. What I mean by that is, for this square root of -3, I can't square root 3, right? But I can square root -1 now. I know the square root of -1 is I. So I'm going to separate it. Instead of saying the square root of -3, I'm going to say the square root of 3 times -1. Because I can square root -1. So I want to pull it out as its own factor so that I could square root it. When I do that with 12, I actually have an additional thing I could pull out. What number can you divide 12 by that you can't square root? 4. So I could rewrite this as 4 times 3. And again, I want to pull out the -1 as well. Yeah, it's going to be a little confusing until probably I'm done with 5. After you see both examples, then I think you'll be like, oh, okay, this isn't as bad as I think it is. But that's the goal. I want to see basically 2 things. I want to pull out the -1 on its own. And I want to look if there is any perfect squares that I can pull out as well. For 3, it's not. That's a prime number. But for 12, there is a perfect square I can pull out, 4. Right? I could do the square root of 4. And then second step is to actually go ahead and perform the square roots.
For these, so since 3 doesn't have a square root, you're replacing it with 1, correct? And then
That's right. Yeah, since 3 doesn't have a square root, all I can pull out is the -1.
and then when you bring out the -1, you're gonna bring it over to the one that you separated, correct? That's
Yes,
all you do.
but do this step first. You're 1 step ahead of me. That's the third step.
Okay.
All right, so the square root of 3 I can't do anything with, so I'm just leaving it the square root of 3. The square root of -1 is, that's the first thing we wrote down today, it's I. The square root of 4 is 2. Square root of 3, again, I can't do anything with, so I just leave it square root of 3. And then the square root of negative 1, again, is I. All right, so you perform each square root if you can. The square roots of 3 I can't, so I just leave them square root of 3's. The square root of negative 1's are I, and then the square root of 4 is 2. Now we're going to do what Vanessa said, which is we're going to combine our numbers. So square root of 3, I can multiply by the square root of 3, becomes the square root of 9. But what is the square root of 9? It's just 3. All right, this is the part where people struggle with. Well, to be honest, they struggle with this whole thing. Simplifying square roots is always a pain. That's why I ended up pushing back the homework so we could do more of these. I can combine with I. I times I is I squared. But look at your notes. What is I squared? It's negative 1. I don't need to put that in parentheses. Why did I put that in parentheses? I squared is negative 1. And then 2, I could just leave as 2. And now I can multiply that all together to get negative 6. Okay, the way I did it there may seem confusing. It may seem strange. It may seem extra that we have to do it this way. But you absolutely do have to do it this way, because let me show you, one of you is going to do this on the quiz. It's going to happen. I know it's going to happen. One of you is going to do this problem like this. The square root of negative 3 times the square root of negative 12 is positive 36, right? Because the negative times the negative is positive, and 3 times 12 is 36. And then the square root of 36 is 6. Is that the right answer? No. The right answer is negative 6. This is not a valid operation. You cannot multiply 2 square roots together if one of them has a negative sign. So doing this is going to get you in trouble, and then you're going to get your quiz grade back, and you're going to see on it a little sad face. Okay, and then you're going to be like, oh no, I made Mr. Lake sad. What did I do? And then you'll look back and see you did this, and you'll be like, no! I'll have to give Mr. Lake like $20 to make it up to him. Or Venmo me. I don't even know what that is. I probably should get a Cash App. I guess a lot of people use it. They were telling me I could pay my fast dues this year by Venmoing them. And I'm like, I don't know what that is. Don't you come at me with your Venmo, thinking I know what that is. All right, let's do this again. You ready? You excited? Everyone in here looks thrilled to be doing the math that we're doing right now. Okay. All right, 48. We're going to separate this into stuff that I can't square root. What is the biggest perfect square that divides into 48? Let's see. Does 4 go into 48? Does. But is it the biggest? No. Does 9 go into 48? What's another? Like 4 squared would be 16, right? Does 16 go into 48? Yeah, 3 times. And that remainder of 3 is a prime number. So I think we have found the biggest number that works, right? So I can represent this as 16 times 3. And again, please pull out the negative 1. So we leave 16 and 3 positive, and we just put that placeholder of negative 1 at the end. What's the biggest perfect square that goes into 27? 9, and it goes into it 3 times. And again, put the negative 1 at the end. Step 2. I'm now going to perform each square root that I can. The square root of 16 is 4. 3 is a prime number. I can't square root it. It would be a decimal, so I'm just going to leave it as square root of 3. And then the square root of -1 is I. Square root of 9 is 3. Square root of 3, I just leave as it is. And then the square root of -1 is I. All right, last step. I'm going to combine my like terms or combine, multiply, all that cool stuff. And it turns out that these are like terms. I have 4 square roots of 3i minus 3 square roots of 3i. So 4 apples minus 3 apples is 1 apple, or 4 square roots of 3i minus 3 square roots of 3i is 1 square root of 3.
Wouldn't it be just 3 since you already did the square root of it? Like, wouldn't it just be 3i, or would you have to keep the square root since the I is there?
Good question. Yes, you do have to keep the square root because in this one we multiplied, but in this one we subtracted. So since we didn't multiply them together, that square root of 3 has to stay there. Great question. All right. Do we hate this sufficiently? No, not too. It's okay. I always hated square rooting. That's the one thing when I came back and transitioned to teach that I was like, teaching the simplified by square root stuff is so pointless. I feel like, can't you just use a calculator? And to be honest, you can until you get to this I step, because every time you try to type this in the calculator, right, it's going to say you can't do it because you can't square root negatives. So your algebra 1 teacher may have said, hey, don't worry about this, just use a calculator. They may have done you a disservice there. All right, I'm going to clear this and move on unless someone says, no, wait. Okay, here's the last thing we're doing today. It is your turn to try it. You try to do these 2 problems. I'm going to give you a hint with this second problem. Simplify this first. In other words, make this -1 plus square roots of 3i first, and then try multiplying it by itself, okay? All right, I'm going to give you 4 minutes. If you get stuck in these 4 minutes, don't sit and suffer. Ask me for help, and I'll get you started, or give you a hint or whatever. I'm gonna give you one hint since we're halfway. If you've been struggling to come up with perfect squares that go into 14 and 2, that's okay. There isn't any. Your first step will be to say that this is the square root of 14 times -1, and this times square root of 2 times -1. That should be your first line. There isn't any perfect squares that go into 14 and 2.
So for these, do you have to use perfect squares or can you use multiples?
For this, you have to use perfect squares. Yep. Because you're right. I mean, if you use 7 and 2 for 14, 7 you can't square root, and 2 you can't square root. So it doesn't help us to break it into those parts. You could just leave it as 14. But keep that in mind. You will end up using that later in the problem. Okay. I know this stuff is tough. Who's really brave right now wants to try to take this problem the rest of the way? Nobody. Nobody. That's okay. It's tough. I still want help though, because math is tough and I don't want to do it alone. Let's roll the dice. 4, 1, 2, 3. Anna! All right, Anna, what would my next line be? Can I square root 14? So we'll just leave that. But what's the square root of I? I said it. What's the square root of -1? Very good. All right. Can I square root 2? Okay. But again, square root of -1 is I. All right. So if I multiply these together, the square root of 14 times the square root of 2 is the square root of. All right. Now here's the key thing. What's I times I? It's -1. Remember, I squared is just the number -1. All right, if you left your answer like this, there's one issue. 28 now does have a perfect square that goes into it. What can you divide 28 by? Yeah. So really, you do have to double check at the end. Did you make a number that you could square root? And we did. The square root of 4 would be 2. So I'm going to write this as -2 square root of 7. Okay. Square root of 4 is 2, and I'm going to go ahead and apply that negative now. I really could have put the negative out in front here. If you wrote this line instead as negative square root of 28, that would have been fine too. Either is okay for your third line. All right. Mr. Lake's feeling generous. I will do the second problem for you because it is kind of tough. If you could do this second problem, I think you have mastered the content that I was teaching you today. So keep in mind, whenever you're squaring something, that means you multiply it by itself, right? So when I say do -1 plus the square root of 3i squared, I really mean multiply it by itself. And to multiply these two things together, I would have to use the distributive property, or FOIL. So -1 times -1 is +1. -1 times the square root of 3i would be negative square root of 3i. Square root of 3i times -1 would also be negative square root of 3i. All right, here's this last one. This last one is really where everything happens. What's the square root of 3i times the square root of 3i? Well, first, what's the square root of 3 times the square root of 3? Square root of 9, which is 3. What's I times I? I squared, which is, so this becomes -3. Oh, I forgot to circle my answer. Right. If I now combine my like terms, I have two pairs of like terms, right? 1 minus 3 is -2. And 1 minus the square root of 3i minus another square root of 3i means I have -2 square roots of 3i.
Where did the 2 come from?
So I've got, think of it like this. I've got -1 minus 1, and -1 minus 1 gives us -2. And how I always think about it when I actually do this in my head is I really, instead of saying this mess, I just put in a filler word like -1 pencils minus 1 more pencil means I'm down 2 pencils, right? And then I just fill back in the filler word with this garbage math. Woo. All right, do you remember doing this in Algebra 2, simplifying square roots by looking for perfect squares that go into them? No. Oh, God. Yes? A little bit? No. I'm getting some hard no's and then some, we did it once. I don't know. I understand because for a lot of people, they'll be like Algebra 2 is the last required math class for some people, right? You usually do Algebra 1, Geometry, Algebra 2, and you have now done enough to graduate high school. So they go, we're just going to cut it. It's too hard. They don't need it to get a diploma. But if you want to go on in math, you do need it. I mean, we're doing it right now. So I don't know. Yeah, what's your question?
It's not about one of these, but I was just gonna ask if you were to get like plus and then square root of I and then minus the square root of I, would it still cancel each other out, or would it not work like that?
Oh, very good. So you're asking like if I had square root of I minus square root of I?
No, like if you had like -1 square root of, like how you have them right here, but if one of them was like addition, would they cancel each other out? Or...
That's right. Yeah, if this was addition, you're right. It would become 0.
Okay.
Absolutely. All right. So this homework is not due till Wednesday. It is in website. If you want to start, you can do, I think, the first 3 or so problems. I would, just while it's fresh, go ahead and start doing those as much as you can tonight. And we will finish, we'll do another one of these as bell work on Monday, and then we'll finish the lecture for 2.4. All right. You all can go ahead and start packing up. Oh no. Actually, I don't know. I always like I. I think it's fun. I think it's fun to do, I don't know, this kind of math. I didn't think it was fun until about 2 years ago. And then I did a grad class called group theory, which showed me another like application of this. And then I was like, okay, this is actually kind of fun now. Do you remember that, who have seen Good Will Hunting? The problem? on the chalkboard that he ends up solving, right? They're like, hey, that's grad school stuff. Get out of here, you janitor, right? And then they beat him up and steal his lunch money or something. That's a group theory problem that they're doing, which uses complex numbers in it to do. Which is why it's kind of like, how would somebody who's just a janitor, you would never be exposed to this math, right? Be able to do that. So there's a whole bunch of really, now the other thing is group theory is like the first class you take in math at grad school. So they act like it's this really complex problem, but if you have been in, you realize, oh, that's not at all that bad. All right, have a good one, everybody. I'll see you Monday. Eat your vegetables. Do 100 push-ups. Drink gallons of water or whatever.